All right, welcome back. So I mentioned that I wanted to try to solve some Kattis problems this time, just kind of practice, and it gets you thinking about algorithms a little bit. So in the same Jupyter notebook, there are a number of Kattis problems listed. And so I just figured that I would start kind of at the top and I would do oddities, maybe cold pewter science, and then Fizzbuzz, which is a classic problem, which is quite a lot of fun to solve. So let's look at oddities first. So every caddis problem has a little bit of verbiage at the top just to kind of give you background on it. So some numbers are just, well, odd. So 3 is odd because it is not a multiple of 2. There are multiple of 2. There are a multiple of 2 that are not odd. They are even. So this is how you can express a number as even or as odd. And so this problem, they will give you an input. So the first line will be an integer between 1 and 20 on a line by itself. So in this sample input is 3, indicating the number of test cases that follow. Each of the following n lines, so whatever number you get in line 1, will consist of a single integer between -10 and +10, inclusive. So in this sample input, we have 3, 10, 9, and -5. For output, for each x, each line here, which is not the first line, um, print either x is odd or x is even, depending upon whether, well, x is odd or even. So I've never solved this one, so I'm going to hopefully not make a fool of myself as I try to solve this. So I'm going to create Kattis Problems. And I'm just going to copy this makefile up there because, well, I'm lazy and I don't want to make a new makefile. And let's see, I'm going to go ahead and do this as audit tease, audit tease, audit tease. And let's go ahead and save that and then create a new file and, well, obviously name it audittease.cpp. All right, so Caddis, you don't actually need comments, but it's a good habit to get into writing comments. At the beginning, date 9/28/21. This is for the audit tease Caddis problem. All right, and just as before, include IO stream using namespace std, int main, return 0. So you should have all of this. And now we need to actually look and see what the problem says. So I'm going to go ahead and copy and paste this, and I'm going to put it up here. Let's see, self, indicating number of test cases to follow, and I'm just going to do all this, and consisting of, all right, so we need to read in a number. We need to read in the first line, and that will tell us how many lines to read in. So for that, we need an actual variable, int num lines. And then, let's see, we'll go ahead and read that in. So cin num lines. So we're reading in that number. And then, let's see, input begins with an integer on a line by itself. So this will be n. I just named it num lines. You could put n, indicating number of test cases that follow. Each of the following n lines. So now we just need a loop. So we can do for int I or int I is equal to 1. I is less than or equal to the number of lines, I plus plus. So because we already read in the first line, it's going to now start with line 2, which will be the first line that we actually care about. And the first line will indicate the number of lines that we want, and then each line after that will be its own thing. So now we just check to see if a number is odd or even. And that, we should all know how to do this, but if not, so if we say, oh, no, actually, first we need to read that in. So now we need, let's just say int current line. So now we can just do cin current line if current line mod 2 is equal to 0 tells us what? Well, it tells us that whatever number we read in from the current line must be even. And so if it's even, then we need to print out this, cout, and x in this case is going to be whatever that number is, current line, and we need a space is even, end line. Otherwise, else, cout, current line is odd, end line. Okay, so we read it in. So we read in the first line, tells us number of lines, tells us how many times we need to go through this loop. Then we read in the line, and so we'll just do this line by line, and we'll do it num lines number of time. And then we check that number. If it's even or if it's odd, we print it out, and then we're done. So let's go ahead and test this. So this is under Kattis Problems. Make, oops, I misspelled make, run. And so let's go ahead and take the sample input. So 3, 10, 9, and 5. So 3, 10, 9, and -5. And so because we're reading this in at the time, as we're typing it, it's actually running through this loop. And this is okay. We can just make sure that this is right. 10 is even, 9 is odd, and -5 is odd. So now we're not actually printing out these numbers as we're reading it in. It's just kind of an artifact as we do this. We can read in all that information and then do the processing, but Kattis should not care. So now let's go ahead and test and see if this actually works. So we could test with other example values. We could say 5 and then type in a value, 2, 4, let's see, it has to be between, well, it doesn't have to be, they just say that will be between -10 and 10, but we'll just do 5, -3, 4 again. And so we get good output for all that. So now we just check and test this. So submit, select here, and then we actually look for it. So I have it under Kattis Problems and Oddities, and I'm looking for the C++ source file. Open it up, should automatically change the language here, and we submit. And now we just wait a second, it will start running. And in this case, it only had 2 tests. That was the first check mark is going to be one of the sample test cases. And then the second test case worked. So this solved that particular problem. Can we make this simpler or shorter lines? Absolutely. And I leave that up to you to try to find a more efficient way of doing this, but there are many, many different ways of solving that particular problem. So the next one I want to look at is cold pewter science. So let me go back over here really quick. I can close out of oddities and I'll just create a new file and name it coldpewter.cpp. And again, I need to modify my makefile, coldpewter and coldpewter. Save that. And just so I have this in my copy buffer, I'm going to go ahead and copy this. Not going to sugarcoat it. Colorado. Sometimes Colorado's can be bad. Chicago's winter can be rough. Temperatures sometimes dip to uncomfortable levels, so on and so forth. So the input is going to consist of 2 lines. The first line contains a single positive integer, n, which will be between 1 and 100, that specifies a number of temperatures collected. In this case, there are 5, or there's 3, and there are 3 temperatures collected. 5, there are 5 temperatures collected. Each temperature is represented by an integer between -1 million all the way up to 1 million. I guess Chicago has a real wide range of temperatures it can be. You must print a single integer, the number of temperatures strictly less than 0. So in this first example, -10 is the only one less than 0, so that's a 1. In this one, we have 5 which are less than 0, so the output is going to be 5. Alrighty. Now, again, I've never actually solved this one, so we'll see if I make a fool of myself. Date 9/28/21, and let's say new line, and I'll just do that, and output you must print. All right, so include IO stream using namespace std int main return 0. And you'll find out if you don't have this return 0 there, it will not accept the solution and C++ will complain, so make sure you put the return 0. All right, input is composed of 2 lines. So we need to read in the first line, int, and this will be the number of temperatures, num temps, cn, num temps. All right, so we read in the first line, and then the second line specifies the number of temperatures collected. Or the second line consists of the actual temperatures, or n temperatures. So we need to read in n number of times. So how can we do that? Well, I can do this. I can create int current temp, and I'm going to go ahead and create a counter. And I'm going to set the counter to 0 just because. Even though it should default to 0, sometimes it's better to get in the habit of initializing variables to a set value. And let's see, how can I read in all of that? So the example they had has all the temperatures on the line separated by spaces. And normally what we do is we do a cn var1, var2, var3, so on and so forth. But we don't know how many there will be, and we can't just dynamically create variables. So can we do this? And I'm not exactly sure, so let's see what happens. So when you do a cn, can we read in the current temp? So that says grab the first temperature. And because it grabs the first thing, which is separated by white space, it should, in my mind, grab the first temperature, store it in there, do something with it, and then once it's done here, go back up and grab the second number because it's separated by white space. New lines don't necessarily matter for this. They're separated by white space. So let's just see if this works. And so if current temp is less than 0, then counter plus plus. So if it is less than 0, because we need to print out the number of temperatures strictly less than 0. And so we just keep this counter running. And if it is less than 0, then we increment that counter. If it's not less than 0, we don't increment it. Once we're all the way done, see out counter. We can put a new line here. I don't think that matters. And so now we just print out the counter. So let's go ahead and make. Oh, I need to do a make clean. Make run. All right, let's look at the examples that they have. 3. I'm going to actually move this over to the side. 3 is on a line, and now we have 5, -10, 15. And so it actually, so that may not actually work. 3, 5, -10, 15. And okay, so let's see, 5, -14, -5, -39, -5, -7. Okay, so the problem is under Linux, when you want to stop entering information, so because we are just saying grab the next temperature, grab the next temperature. We don't have a way to tell it to stop or that we're finished entering the temperature. So in Linux, if you type in 3 and then I'll do 5, -10, 15 and press enter, it's still going to wait for you to enter another temperature. It doesn't know that you're done. If you press Control D on a Mac, it may be Command D, but if you do Control D, that says I'm done entering numbers. And so that is why we're getting this one here, which is the correct answer. And that's why also if I do 5, -14, -5, -39, -5, -7, and I can press Control D won't work there. Oops, I did not mean to close out of that. Let me see, users, presentation, projects, CS1. And then we are under Kattis, run. Then we had 5, and then what were the numbers? -14, -5, -39, -5, -7. And pressing D doesn't do anything. Pressing D a second time actually does put out that 5 there. But normally if you just press enter and you do -D on the same line, let's see, -5, -7, enter Control D, then it says that you're done and it prints out whatever the output should be. So because our output matches these two, let's go ahead and submit it and see if it works. Again, so now we're doing cold pewter or cold putter, putter, one of those. So it's compiling and oh, we got green check marks, and it's running through and we matched all the cases. So the bigger problem wasn't so much, so this is a new thing, but that is just saying keep grabbing stuff until you're told it's done. And so when you're on Linux and you want to tell it it's done, you press Control D. And that's when you're doing an input. 5, -14, -5, -39, -5, -7. And then you're done with this and you press Control D, and that will tell your program, this while loop, I am done. And so then it's a special command character, which then runs this cout and prints it out on the screen. Caddis automatically handles that, so that's why it worked. All right, so this last one will be, it's a good one, Fizzbuzz. Fizzbuzz is a good problem. And this used to be a classic programming question that candidates, when they were interviewing in a business, would be asked. I know that Google and Amazon used to use this to try to gauge whether or not a programmer could think on their feet. So it's a group word game for children to teach them about division. May or may not be true, but this question is generally used to quote unquote torture / screen young computer science graduates during programming interviews. So the concept of this is pretty easy. You're given 3 numbers, X, Y, and N, and all 3 numbers will be between 1 and 100. N is so print integers from 1 to N, which is going to be this number here, the last number, replacing the ones divisible by X with fizz, and the ones divisible by Y with buzz, and the ones divisible by both of these with Fizzbuzz. So there's 7 numbers here, there, and this one there's 7, this one there's also 7, they just happen to choose 7 for that, so that's why there's 7 lines. You either print out the number if it's not divisible by those, so 1 is not divisible by 2 or 3. If it's divisible by just 2, you print out fizz. If it's divisible by just 3, you put out buzz. So this would be 2. 2 is divisible by 2. 3 is divisible by 3. 4 is divisible by 2, and so you print out fizz, 5 obviously. And then 6 is divisible by 2 or divisible by 3, so it's divisible by both of those. So you print out Fizzbuzz. So let's go ahead and I will show you one solution, and you can come up with your own probably better solution. So I'm going to name this fizzbuzz.cpp, and I'm going to modify the make file, fizzbuzz and Fizzbuzz. And again, programmer information and date. We're still on the 28th, 21. All right, so input contains a single test case and print each on their own lines, placing the ones divisible by x with fizz, the ones divisible by y with buzz, and ones divisible by both x and y with fizzbuzz. So include IOStream using namespace std, int main, return 0. All right, so our input is going to be a single line, a single test case, and it will have 3 values in there. So I'm just going to do x, y, and n here just because. Int x, y, n, and we can just easily read that in. Cn x, y, n. So we're just reading that and then storing it into each individual variable. And so now what do we have? So we have print integers from 1 to n. So that sounds to me it's a for loop. For int I is equal to 1, because it's saying from 1, I is less than or equal to n, I plus plus. Okay, so now if we don't do anything else and we do a cout I end line, we will get numbers 1 through whatever n is. So that is part of something that we need, but we don't actually need that yet. So now we check. So I'm going to go ahead and write this way here, replacing the ones divisible by x with fizz. So how do we check that? So what does it mean divisible by x? Well, I mean, if you divide a number by that, an integer division will get you, well, it will get you an integer back. But if we do a modulus, that will, and the modulus is equal to 0, that will mean that it's divisible by that number. So if we do I mod x is equal to 0. And if we do this, we do cout, and then do we need to print out the number or anything? I think we just print out fizz. Yes, just print out fizz. Cout fizz end line. So if the number is divisible by x and the remainder, so if the number mod x is equal to 0, then it's divisible by that. So we print out fizz. Else if, let's see, the one's divisible by y with buzz. Okay, so y, or I mod y is equal to 0. So now we print out cout buzz end line. Otherwise, the one's divisible by both x and y with fizzbuzz. So now we can't do an else if. So I kind of wrote myself into a corner here. Because, see, I was thinking if I can do an else if I mod x is equal to 0 and I mod y is equal to 0, then cout fizz buzz end line. And so why will this not work? Well, because we're saying if it is equal to, just I mod X is equal to 0, print out fizz. Don't do anything else. So how do we fix this? So a couple of thoughts. I can change the order of all these. That might be the easiest. So if I make this an else if, and I put this up here, so I'm going to go ahead and cut that and paste this here, and put a space there. So if I do that first, we'll print out Fizzbuzz, and then it won't do the fizz or the buzz. But otherwise, if it's not divisible by that, then it will print out fizz or buzz. Else, you can see out just the number. End line. Yeah, that'll work. So that's the first thought. There is another thought that I have. Let me make sure that this actually works first. Make clean. Always forget to do that. Make run. And let me go ahead and take the sample cases, 2, 3, and 7. 2, 3, 7. 1, fizz, buzz, fizz, 5, fizz, buzz, 7. And so we get 1, fizz, buzz, fizz, 5, fizz, buzz, 7. So that's good. Let's try 2, 4, and 7. 2, 4, 7. 1, fizz, 3, fizz, buzz, 5, fizz, 7. So that's good. And then just for sanity sakes, 3, 5, 7. 1, 2, fizz, 4, buzz, fizz, 7. All right, so that works. So this way will work. But there is probably an easier way. So let's say, because with this, I'm doing several checks. And this check here, and each one of these checks is kind of redundant. So what if, and I'm just thinking out loud here, what if I do this, but then I don't print an end line? Will that work? So it'll print it out, print that out. So this actually won't entirely work. I would need to do 2 separate ifs. So then I print out fizz, print out buzz, and then so this won't work. But the key thing is I'll need a cout end line. This, if it is not either one of those. So print out fizz, print out buzz, print out an end line. But if it's not that, can't really do an else there. I still probably need an if, and I could also do, I could do a not I mod y is equal to 0, or I mod x is equal to 0. So if those are not that, cout I. So does this actually work? So 3, 5, 7. So 1, 2, fizz, 4, buzz, fizz. That works. And what was one of the other ones? 2, 4, and 7. 2, 4, 7. 1, fizz, 3, fizz, buzz, 5, fizz, 7. So that does work. But instead of having the if, else if, you have 3 independent ifs, and you just don't add a new line until the very end. Because you're always going to add a new line, whether you print out fizz, buzz, fizz, buzz, or you print out the number, you're always going to have to add a new line at the end of that. With this, you're just printing out fizz, and then you could also print out fizz buzz if it happens to match there. You still do need this check here to make sure that it is not, if it's not one of those, then you have to print out the number itself. So let's go ahead and just verify that this actually works. And let's go ahead and choose Fizzbuzz and C++, and let's go ahead and submit. And we wait, and we got green check marks, and we got green check marks. So this solution was accepted. So both solutions would actually be accepted. So hopefully you enjoyed this, and go ahead and definitely try out several, if not all of these Caddis problems, because some of them are quite fun to actually solve, and it's good practice. The more you program, the better you become. So thanks for watching, and I hope you enjoy your weekend.